Welcome to the DIY Honda Garage channel. DTC B1177 indicates an abnormal battery voltage issue that can impact the functionality of the vehicle and potentially the gauge control module. The gauge control module, which includes the tachometer, is an important component that displays critical engine information such as engine speed. When DTC B1177 is set, it suggests that the electrical system is not functioning as expected, which can create issues with other electronic components. An improper voltage supply could lead to inconsistent or inaccurate readings on the dash, making it crucial to diagnose this error correctly. It's important to ensure all steps are followed in the diagnostics to identify any underlying problems, whether it's a bad battery, poor connections, or the gauge control module itself. The DTC B1177 pertains to an abnormal battery voltage condition affecting the functionality of the gauge control module located within the dashboard area of the Honda Civic. This gauge control module includes the tachometer, which is essential for displaying engine RPM. The module's role is to receive voltage from the battery and convey engine information to the driver. Abnormal voltage levels can cause the gauge control module to operate outside its designed parameters. Therefore, if the voltage is too low or too high, it could result in the malfunctioning of the dashboard instruments, making it imperative to diagnose and troubleshoot the issue promptly. Several underlying conditions could result in DTC B1177. First, the battery may be discharged, meaning it does not hold enough voltage to power the electrical systems properly. Second, there could be a charging system malfunction, which affects how well the alternator charges the battery. If the gauge control module itself is faulty, it may not process voltage signals correctly. Identifying these possible causes is crucial when troubleshooting to ensure that the right repairs are made. Each possible cause needs to be examined step by step to determine the root issue without overlooking potential symptoms of the problem. The symptoms associated with DTC B1177 can significantly affect vehicle operation. One of the most immediate symptoms is potential dashboard gauge problems, where displays may not function accurately or at all. This can directly impact the tachometer, leading to unreliable readings of engine speed, which is crucial for driving. Additionally, there might be issues during engine starts. The vehicle may not start properly if there is insufficient voltage. If the battery status is low, it can trigger warning lights on the dashboard, indicating a need for urgent attention and intervention. Recognizing these symptoms enables quicker diagnosis and resolution before more severe issues arise. The first step in troubleshooting DTC B1177 is to clear the diagnostic trouble codes DTCs using the HDS or Honda Diagnostic System. This step resets the system's memory of any fault codes that have been stored, allowing for fresh diagnostics. By clearing existing codes, we set a clear baseline to observe any new codes that may surface after subsequent tests. This helps isolate the specific issue without being influenced by previous faults that may no longer be relevant. It is important to perform this step with precision to ensure an accurate diagnosis moving forward, as lingering codes can complicate the troubleshooting process. After clearing the DTCs, turn the ignition switch to the lock position and then back to on. This action serves to refresh the vehicle's systems and can help in establishing a new diagnostic state. Ensuring the ignition is in the correct position allows the onboard computers to recalibrate the electrical systems. By cycling the ignition, we also prepare the vehicle to check for any new DTCs that may arise as a result of the reset. This step is essential in ensuring that subsequent checks are valid and reflect the current operational status of the vehicle. Following the ignition switch cycle, The next step is to check for any diagnostic trouble codes with the HDS. It's crucial to perform this check right after the ignition cycle, as it determines the next course of action based on whether DTC B1177 persists or not. If DTC B1177 is indicated again, it confirms that the system is still recognizing an issue with battery voltage. Conversely, if the code does not appear, it may indicate an intermittent failure or that the vehicle corrected itself, such as through a battery recovery process. This distinction is vital in directing subsequent troubleshooting efforts effectively. If the previous step does not indicate DTC B1177, clear the DTCs with the HDS once more. Repeating the clearing process allows us to remove any recent error messages that may not be relevant to the current condition of the vehicle. By doing this, we ensure that we have a clean slate for monitoring after further tests. It helps to eliminate confusion from previously stored codes that may not reflect real-time issues. This repeated clearing is necessary to confirm the stability of the vehicle's electrical systems and prevents misdiagnosing faults that are no longer applicable. Once again, turn the ignition switch to the lock position and back to on 2 after clearing the DTCs. This step repeats the ignition cycling process, allowing the onboard computers to reinitialize their systems. It serves the same purpose as before, ensuring all components are synced and ready for the next checks. This regular cycling prevents erroneous readings and ensures the electrical components communicate effectively to identify any further issues. Being diligent with this step allows for a more accurate assessment moving forward, as any lingering or intermittent issues may reveal themselves during further diagnostics. At this stage, it's time to crank the engine. This action engages the electrical system under load and is critical to observe how voltage is distributed during startup. Cranking activates the starter motor, which will draw power from the battery and offer insights into the state of the electrical systems. By doing this, we can determine if the symptoms of voltage abnormalities resurface, which can lead to DTC B1177 being triggered again. Understanding how the vehicle's electrical system responds during cranking is vital for diagnosing not only the battery condition, but also the functioning of related components, including the alternator and gauge control module. After cranking the engine, the next step is to check for DTCs again with the HDS. It is essential to perform this check immediately after the engine cranking, as any fault codes that appear now may provide critical insights into the condition of the electrical systems during startup. If DTC B1177 is indicated, it confirms a persistent issue with battery voltage supply that needs deeper investigation. Conversely, if no codes are found, it suggests the fault may be intermittent, pointing towards potential sporadic issues like a momentary weak battery or wiring problems that might not show consistently. Gathering this information is a key step in diagnosing the root problem effectively. If DTC B1177 is indicated again, the next step is to thoroughly test the battery and check the charging system. The battery test helps determine whether it is capable of holding adequate voltage under load. This is crucial, since a defective battery may not provide enough power to the vehicle's systems, triggering DTC B1177. Additionally, evaluating the alternator and overall charging system ensures that it is functioning correctly, facilitating appropriate battery recharge during operation. Inspecting these components allows for quick identification of issues surrounding power supply. If either the battery or the charging system fails to meet specifications, they should be repaired or replaced appropriately. Next, turn the ignition switch to the on position while leaving the gauge control module, TAC 36P connector, connected. Measure the voltage between the gauge control module, TAC, 36P connector, terminal number 17, and body ground. This measurement will indicate if the gauge control module is receiving sufficient voltage for operation. If the voltage reads above 7.5 volts, it confirms that the module is powered appropriately, and replacement of the gauge control module is warranted if issues persist. If the voltage is below the required threshold, it indicates a possible wiring issue, such as an open or high resistance in the BRN wire between the ignition switch and the gauge control module. Diagnosing this appropriately is crucial for ensuring that the module functions correctly in providing accurate engine readings. After applying necessary repairs based on previous troubleshooting steps, the final verification step involves using the HDS to ensure that all repairs have resolved the issues. This includes checking the DTCs to confirm if they have cleared successfully and validating that no new codes are present regarding the battery voltage or gauge control module. It is also advisable to monitor vehicle performance under various operating conditions to ensure that everything functions as intended. This verification is critical, as it guarantees that any repairs made will hold up under normal driving conditions. Performing a thorough check ultimately leads to enhanced reliability, reducing the risk of repeated issues. To prevent future occurrences of DTC B1177, conducting regular maintenance checks on the battery is essential. This involves checking the battery's terminal connections, ensuring they are clean and free from corrosion, which can lead to voltage irregularities. Regularly inspecting the battery's charge and replacing it when necessary helps maintain its performance. Additionally, checking the wiring connections between the ignition switch and the gauge control module is vital. This will catch any signs of wear or electrical resistance that could cause problems later on. Adopting these preventive maintenance measures will greatly enhance the reliability and efficiency of the electrical system in the Honda Civic. In summary, DTC B1177 indicates an abnormal battery voltage issue affecting the gauge control module within the Honda Civic. Through systematic troubleshooting and verification steps, one can accurately pinpoint the root of the issue, whether it is the battery, charging system, or the gauge control module. Addressing potential causes with care is critical for maintaining the vehicle's electrical integrity. Implementing preventive maintenance practices will aid in alleviating similar issues in the future, providing a better, more reliable driving experience. Regular diagnostics, similar to those outlined in this guide, play a vital part in ensuring the longevity and proper function of vehicle electronics, underscoring the importance of ongoing vehicle care. Please like and subscribe to the channel. See you next time.